this will be useful in interview and most of the technical test. So here we will focus on these fundamentals, the basic fundamental differences I have given in this video. So it will be useful for you. So the first one is temperature versus heat. So this is one of the important difference and which plays a crucial role in thermodynamics. So as you know, temperature is a measure of how hot or cold body is finite, or it can be tell the kinetic average kinetic energy of the material it has. So this is also said to be a temperature. So if we come to heat, heat is a form of energy transfer due to temperature difference. So it's a form of energy transfer due to the temperature difference. One side it has some amount of temperature, on the other side it has temperature. So due to the temperature difference, there will be energy is transferred. That energy is said to be a heat. So this is a basic difference. Simply you can say a measure of how hot and cold a body is, and then heat is a form of energy transferred due to temperature difference. And next one is tube versus pipe. As you know, tube is defined by outer diameter used in structural and heat transfer applications. As you know, in the cell and tube heat exchanger and many of the condensers, it plays a crucial role in the heat exchanger process. And also, tube is used in small scale applications wherever, for example, if you talk about a vehicle, in the vehicle, the petrol from the petrol tank to the cylinder combustion chamber, there will be a tube which transmit the petrol fuel. So this is a small scale application. Small scale application means it is used in a small transferring medium. That's a very important thing. And the pipe, next one is pipe. Pipe is defined by inner diameter, whereas it is defined by outer diameter. It is inner diameter, use it for fluid support, fluid transport. So this plays a crucial role in large scale applications. Next one is stress versus strain. This is a basic entry equation. Stress is a force applied per unit area in a material, and the strain is deformation, change in length or shape due to the stress. In strain also we have three type of strain, as you know. And then the next one is torque versus power. Torque is a rotational force. As twisting, you can say it as a twist. So it is a kind of a twist. So it is a rotational force, as you know. And then power is a energy per unit time is a basic definition. And also it is said to be a rate of doing work, depends on the torque and the angular velocity. So for power we have n number of definitions in electrical and in mechanical, and in many of the applications they have different kind of definitions. So this is a basic difference between torque versus power. The next one is mass versus weight. Mass is the amount of matter in a body. It will be constant. Always the mass will be constant anywhere else. If you go anywhere, for example, if you go to moon, the mass will be constant, but the gravity will change. The weight is a force due to gravity acting on mass. Force weight is equal to mg. So due to the depends on gravity, the weight will vary. The next one is work versus energy. As you know, work and energy has the same unit. So what is the difference? Work is a force into displacement in the direction of force, whereas energy is a capacity to do work. It can be a potential energy, kinetic energy, etc. So this is a basic difference. If they ask work directly, you can write as a formula as a force into displacement in the direction of force, whereas in the energy is a capacity to do work. That's a very important thing. And the laminar flow and turbulent flow, it is a very basic question in fluid mechanics. Laminar flow is a smooth, orderly fluid layers which has a structure, a boundary layer, a velocity profile of parabolic in nature, whereas turbulent is a chaotic, irregular mixing flow due to the high Reynolds number. It has a high velocity, whereas laminar has low velocity. So for turbulent, it has a high velocity. It has a linear, sorry, it has a constant velocity profile for turbulent. And then conduction and convection. Conduction is happens only in solids, whereas convection happens in liquids or gas wherever a molecule is moving. So that is said to be a convection. Next one is elastic versus plastic. Elastic as a material returns to its original shape. For example, if you take a rubber band, if you expand it some amount of force, if you giving some amount of force, after some time it will retain its same position or its original shape. So that is said to be elastic. Plastic means it will not come to its original shape again. There's a permanent deformation after a load removal. That's a very basic difference. And then open system and closed system. Open system can exchange both mass and energy with the surrounding. Example boiler. But for boiling, we are using external energy, fire, and then from that mass also getting transmitted from liquid to vapor, and then energy is also getting transmitted. Then closed, only energy is transmitted. We will give a heat in terms of fire or any kind of fuel what we are using, but the mass will not be transferred because it is closed. So that mass will not be transferred as vapor. Example is a piston cylinder without a leakage, wherever you are using real-time applications. And then centripetal force and centrifugal force. Centripetal force is a real force directed towards the center of circular motion. It directs to the center of circular motion. That is a very important thing. Whereas centrifugal force is an apparent force felt away from the center due to the inertia. Centrifugal, as you know, in the centrifugal pump, due to the force felt away from the center of the axis, it will experience some amount of force. That force is said to be a centrifugal force, and then it's also said to be a body force as well. And then static friction and kinetic friction. Static friction, force resisting motion when body is at rest. The force resisting when the body is at rest. For example, if you keep a note in a table, that note will experience some amount of a resisting motion. That friction is the static friction. Kinetic friction is the force resisting when the body is sliding. That's a kinetic friction. Sliding is a, and then for rolling friction, when the body is rolling, you will get a rolling friction against it. This is a basic difference. An IC engine and a AC engine. IC engine, internal combustion engine, fuel burns inside the cylinder as you are using in the vehicles, day-to-day vehicles, petrol, diesel engines. External combustion engine, fuel burns outside. It's a steam engine, steam boiler, steam turbine. It's an external combustion engine. Gas turbine is also external combustion engine. And then compressor is a pump. This is one of the important question. Compressor increases pressure of the gas. We are using in day-to-day applications. Compressor will get the gas from the atmosphere, and then it will compress with the help of the piston. It may be a single stage or a double stage compressor depending upon the application. Due to that, the gas will be compressed in high pressure, so it will be used for the further use in a CNC machine and many of the cleaning process as well. So pump is used to increase the pressure and flow of a liquid. That's a very important thing. And then generator versus motor. Generator is converting mechanical energy into electrical energy. For example, if you are using in the home, if you are using a generator, it is used mainly for making electricity. So generator converts mechanical energy into electrical energy, and then motor converts electrical energy into mechanical energy. So vice versa. For in home, we are using a motor to transfer the water from the base level to tank. For that, we are giving electricity by switching on the switch. Due to the electric energy, it will make movement in the rotor. Due to that, mechanic and then converted into mechanical energy. That is a very important basic thing. For more information, follow this channel. I hope this video is useful for you. Thank you.